yes. And I work for a Portuguese Society for the Study of the Birds. But I'm here to representing the festival, the birdwatching festival. And Sonia is my colleague. She also works for a Portuguese Society for the Study of the Birds. And she will present you, Rory, better about the festival. I think most of you are at your home, but for the people that don't know the festival, we are having around 200 activities happening this year in a different way. This year we have the same kind of activities, but with less people, with different rules, as you can imagine. And online, we have the online festival. And you can also register in the next webinars that we'll have during the weekend and Monday. And the link will be at the program, so you don't have to wait for the email, because probably they will insert a link in the website. Okay, so now Sonia will present Rory, okay? And I'll be here to just control the webinar, okay? Sonia?
Okay, thank you, Joanna. One thing I would also like to ask is, especially for the non-native speakers of English who are watching us, if Rory and I get excited and start speaking too fast, please drop a note in the chat and Joanna will signal to us to slow down a bit. So as Joanna said, my name is Sonia. I work in the communications department at SPEA, and I'm very happy to be able to talk to Rory and to give you guys the opportunity to talk to Rory today. So Rory Wilson is a professor in zoology at the Department of Biosciences at Swansea University in Wales in the UK. And he's developed these tiny little devices that he calls digital diaries, the sort of loggers that basically allow him to figure out what animals are doing when he can't see them. And so, Rory, can we jump right in and maybe show people what this thing is that we're going to be talking about? And maybe you could tell us a little bit about how you came to design this.
Sure. I mean, I wish I could say I designed it. The bloke actually designed it. I noticed has signed in, a chap called Mark Holton. So he does all the clever stuff. I just do. I just say, I think this would be a nice idea. What do you think? And Mark says, yeah, that's possible, or it isn't. Let me just tell you about them though. Here's one, not the smallest version of the tag, and you won't be able to see it very well because I'm holding it up like this, but what I can do is I can share screens with you. Mark has sent me, I'm in Germany at the moment, and Mark's in Swansea. Screen to share. Can you see that?
We can.
Great. So this is the latest version of it, of the tag, which we call the daily diary, and we're calling this one Alice. Just.
Are you meant to be showing us the photo of it?
Yeah. Can you see the photo?
That's not what we can see. We can see your Zoom window with little something else on top.
That's really weird. I've got the wrong window then. Wait a second. Stop share and start sharing again. How did you find that, everybody? Was that marvelous? Share screen.
Riveting.
Riveting. Now, it has to be screen 2. So, how about that? Is that better?
Now we've got it.
Okay. Thanks. I'm getting a thumbs up from Mark, which is great. Okay. So, those are Mark's fingers. If you look at him on the video things, you'll actually see he's a normal-sized human being. So, these are fingers. That gives you an idea of how big this tag is. And this little thing records acceleration in 3 axes, magnetic field intensity in 3 axes. I won't bore you with the details, pressure, temperature, stuff like that, and records them at screechingly high rates. And the question you'll be asking me is, why do you want to bother with that? Because a small thing like that, you can obviously put on quite a small animal. And I thought the best way for you to appreciate it was to just give you some data from an animal and just walk you through it. If you get bored, you can wave and then I'll stop. But this is a Magellanic penguin, penguin that lives in Argentina, in Chile. And I just thought I'd start you off very gently. And let me explain to you here, these 3 colors here blue, red and green are the acceleration. And basically when they change position, it means there's a change in body orientation. This is pressure, this is magnetic field intensity, and this thing at the bottom here is energy expenditure. I've taken a couple of channels out to make it seem easier. But what I've also done, and this comes from, this visualization is all Mark's software. So not only does he do the hardware, but he does the software that goes with it. He's also very cleverly, for students, put in a system so that we can see an animal performing whatever the animal was performing when it was wearing the tag, more or less. So here's the bit that's going to interest us to begin with. See how the red goes from here to here? What that actually means is the bird has gone from lying down to standing up. You see the penguin there? It's sort of, it wasn't lying completely flat, but it's sort of leaning forward. We're recording these 40 times, each of these channels is being recorded 40 times a second. So the first thing is, you can look at that, it's taken it, well, I don't know, a second and a half to stand up. And all this stuff here, there, the bird hasn't moved. All this is calling. It's calling because its mate's there. And it's actually going to go to sea. So if we just bounce along this track here, this period from here to here, for example, if it just standing there is 11 minutes. And then you'll see a lot of stuff happening here with this accelerometer. And you'll also see the energy expenditure going up. You see here, and we'll just look at that in slightly more detail if we can zoom in on it. And what you see here is, well, I'll take it from here to say here. So you can see this little bit here is where the bird shakes itself. So it's gone, just shake for like half a second. And then it started to walk. And each of these is a footstep. So that's the left leg, that's the right leg. Left leg forward, right leg forward. Left leg forward, right leg forward. So it just gives you an idea of the incredible, unprecedented detail. If you want to count how many steps a Magellanic penguin's taken to get to the water, you can do it. So here it is, going along on its path to the water. We'll just zoom along in time. There's a slight pause, and I'll bet you any money if we zoom in on that bit, that'll be a shake as well. They like to stop and have a shake. There it is. A little shake and then a bigger shake. You see that? It shakes its body. Okay, so we'll now pop along a little bit further. And then what you see right here is the bird has, you see that the red line has moved from this position to this position. And if we put the bird there, it's basically gone from upright to swimming. If I can animate this, there you are, boom, as the bird's laid down in the water and started to swim. And this is the bird's first dive. Okay, in the same way as we could see the footsteps, you can actually see the bird speeding up as it goes. They always do this when they just get close to the water. They just can't wait anymore, and they sort of go and run in. So you can see more energy. Jumps in the water, says "woohoo! I'm in the water." And instead of these lines now being footsteps, these are flipper beats. So there's a flipper beat, there's a flipper beat, there's a flipper beat as the bird swims away in the water. So let's just see the first stage of it in the water. And what you'll see is there's this red line here is the depth. So these are small dives. And this mess here is a penguin having a wash. So it swam for maybe 4 minutes away from the shore during this period. And then it went for this crazy washing period for up to about here, which I'm just looking at it. Yeah, 14 minutes of thorough washing. So don't let anyone tell you that penguins are dirty. They're really clean. Okay, let's follow it along a bit. This is the sort of resolution we have of animals. For every second, they're wearing the tag. So these are now the dives coming in. They're all compressed. This is going down in the water column and up and down and up and down. So some dives going along here, another bit of a wash here. You should be getting familiar with this. A few more dives, a bit more washing. Let's just inspect 2 dives just to show the principle of what's going on here. So let's have a look at maybe this one here. First of all, so let's highlight that dive. In fact, I'll animate it because, like I say, Mark's got us a penguin that can be animated. And here we go, watch. So the penguin starts to dive here, dives down. These are the flipper beats you see here. Very big flipper beats, very, very regular.
So that's the red.
That's the red and the blue. It's been replicated in the blue as well.
Mm-hmm.
And then as it swims along the bottom, this is a 40-meter dive. So you'll notice the flipper beats in both the red and the blue get less intense. And as it comes up, they get less and less and less. And from about this position here, there's no more flipper beats till it gets to the surface. Okay, and that's because the bird's it's buoyant, and so it's like a football. The air which was compressed during the dive then expands in volume, and it pushes the bird up, so it relaxes all the way up from here to here, which is about the last 10 meters. There's no flipper beats. Okay, so that is a dive where the penguin has gone down, swum along, and come up, and it's very regular and predictable, and it's looking for fish, and it's found nothing. Okay, let's see if we can find a dive where it has found something. And this one, I think, is one of those. So let's have a look at that. And I'm cheating because I saw this earlier and I thought, wow, this is an amazing dive. Zoom in on it for you. So here's the dive. We're going to make the bird dive again in exactly the same way as we did. And I'd like you to, because you're all becoming experts at reading accelerometers now. Oops, done the wrong thing. You've got to remember all the, it's like flying Starship Enterprise. There you are. So the bird's coming down. That's the angle it's diving down at. Very big flipper beats to begin with. Relaxing here. And then at this point, see what happens to the flipper beats?
They really speed up, right?
Yeah, it really speeds up and it goes down to the, and then starts to come up. And it stops flipper beating already here. You see that? They're starting to slow down. And this whole last period, the bird's not flipper beating at all. We can, if we want, zoom in on this bit, just so you see what craziness this is. This bit we've looked at, look how the flippers have, really powerful beats, really high speed beats, and this is where the last few meters of the chase were occurring. But this is a dive where the bird, I wrote it down here, at 74 meters, then went hurtling down to 102 meters to catch that fish. Okay, that's 4.2 meters a second, which is just over 15 kilometers now at 70 meters, 70 to 100 meters. I mean, if that's not crazy, what have you had to eat your supper by doing that? You'd never eat again. An extraordinary thing. And of course, this dive is in total actually not a particularly long dive for a Magellanic penguin. I think in total it's about 1 minute 50 seconds from there to there. You can see very clearly. But the reason it's going to be so short and the bird just drifted up is because it used all its energy, and energy means oxygen as well, during this chase, which was 9 seconds of craziness as it went down from here to here.
And you can see that in the spike at the bottom, right? Because you were saying that was the energy.
Yeah, exactly. If you look at this, where this is highlighted here, this is the energy going down, and then it suddenly picks up here and then goes absolutely wild here in this last bit of the chase where it was going left and right and rushing after the fish. So the point about it is that, this is an example from a Magellanic penguin, but we can get a huge amount of detail about what animals are doing, all sorts of animals, using this generic tag. And before I'll just turn this off. What I will do is I'll put this on. This is something that Mark has also prepared, and is a whale shark wearing exactly the same tag off Ningaloo Reef. So here we are in Australia. Actually, there's Mark's cursor showing. So that's the area it is, and the tag, which has information on the in this case the shark's heading and depth and how much energy it's putting into powering itself and these sort of things, will allow us, even though this shark is underwater, will allow us, and miles away from land, will allow us to get information on exactly what it's doing, even though GPS wouldn't work, because GPS doesn't work anyway underwater. There's the land over here. This is the tip of Australia, and here's the contours of the water underwater, which Mark has superimposed together with the fish track. That gives you an idea of the sort of scale we're talking about. And also, this is the dry, arid bit of the land. To find your animal again when you use this program, Mark has left a big pointer. So you go down with the pointer, and there it is, this tiny little whale shark, which is in fact the biggest fish in the sea, which becomes tiny and insignificant and small when it's compared to the vastness of the ocean. The cool thing about this sort of animation is it tells us, we have to get the tag back to do that. We normally tag the shark on the fin there. This is work done with Brad Norman, who's been researching whale sharks for a couple of decades now. And we're interested in how these sharks are influenced by tourism, by boats, what features the environment they're honing in on when they want to feed, and so on and so forth. You can see, basically, if you found the raw data, or looking at the raw data complicated, well, this is another way that you could look at it, because you don't have to understand the raw data. There's its tail beating very slightly, you see there? Tail is actually beating faster than that, but when you zoom around it, it basically slows it down. And as I say, this is the seabed. And it's looking at an animal like this. You can choose how close or how far away you want to be, or above it or behind it. And as you can see, Mark's flying around it. And you can see here that it's going down, it's diving down now. And the question is, if you just had depth and no position, you wouldn't know that the shark had turned, because it basically reached the bottom and then went back up again. So the point about all this is, I won't go on too much. The point about this is that you get incredible, unprecedented levels of detail from this sort of tag about the way animals. Have I done stop share? Have I left?
Yeah,
have I done it?
You have.
About what animals do. So really, that's the idea.
So, and what do you learn from this, though? So, okay, that penguin was walking around and it was shaking itself and it was diving and whatever. Why is
that important?
Yeah, exactly. Why would you want?
Well,
aside from just being cool, which it is.
Yeah. I mean, it's true to say that it seems trite when you say we can count every footstep and every fish they swallow and da da da. But actually, the principle behind the tag is it gives us, if you could see everything that an animal does, then if you have an issue you wish to treat, and that issue could be what do foxes do when they cross a road? Are they bothered by roads or not? How many fish do Magellanic penguins at a population of 2 million in the globe, how many fish do they take? Or are they having a difficult time energetically? Or are they spending all their time looking for fish and not finding it, for example? There are all sorts of things that can be conservation orientated. That's the idea, I think, primarily conservation orientated. But because it's effectively like having a camera on the animal wherever it is, it can be a condor flying a mile above the earth, or a whale shark a mile underwater. You can go back and see things that you couldn't possibly see before, and then you can answer questions you couldn't possibly answer, which may be important questions.
So can you give us maybe an example of a question that you've answered with this that you couldn't look at another way?
Well, I mean, an example of of a question we wanted to know was, how hard are Magellanic penguins working? There's a lot of seabirds, as you will know, have problems with fisheries. Fisheries taking a lot of the resources out of the sea, and it's actually really difficult to know how animals are faring. You can look at the chicks in the nest and say they're not growing as fast as they should be, but what is the reason they're not growing as fast as they should be? Is it because the adults are foraging in the same area and just not finding as much fish as they should be finding? Is it because they're going much further to find a rich resource and normally they don't have to go that far? Or what's going on? Are the fish around? And so, for example, using this and Magellanic penguins in Peninsula Valdez in the colony, we've discovered that penguins are really having it easy. They have a great time. And what's cool about that is because we suspect that there's going to be overfishing, and it's really nice to get a baseline on animals before it happens, because you say, I did my PhD on African penguins in South Africa, and the population was plummeting. And so I was working with much less sophisticated technology than this to try and find out what was going on. And I could find out sort of what was going on, but I didn't know what the norm was. And so getting baseline data for a lot of animals using this sort of technology is really critical.
Okay. There's one thing that I think we should maybe clarify with this. You touched on it, but it might be good to repeat, which is that, so all these things you were showing us about how that data works, you don't get any of that sort of live in real time. It's not that the animal is transmitting the data back to you, is it?
No, no. I mean, it's that, you know, when we sat down with Mark and said, you know, how are we going to build this tag? What do we need to do? And all the rest of it, I say we, I mean Mark, because nothing happens without him. Then, you know, the question is, do we want to get some data beamed back, and poor quality data? I say poor quality, you can't beam all that information back. It's just not possible. Or do we want to go for a sort of Rolls-Royce type tag, where if you don't get the tag back, you get nothing. You have nothing in real time, you have to get the tag back. If you get the tag back, you've got the jackpot. But the reason we went for that is firstly because there wasn't a jackpot tag out there, firstly. And secondly, because it doesn't matter how much you want to beam data back. There are animals like sharks that cannot beam the data back. With a whale shark, you know, you just can't get that volume of information through the water by any means. So that's the Achilles heel.
Okay. And I know that when we've chatted about this before, you told me a couple of stories of when the data revealed things that you weren't expecting. And I remember the story you told me about the albatross, which I think is a very cool one. By the way.
Yeah. Oh, yeah. Well, that's the cool thing is about this sort of technology, because if you imagine, it's like I say, it's like having a video camera on an animal that you normally would never ever see doing its stuff. And there was a particular case where we had a South African girl, and she was looking at wandering albatross data for wandering albatrosses, and we were interested actually where they were feeding and if there was an overlap with fishing vessels and so on. And she came to me, and she was looking with this program, DDMT, Mark's program, and she said, "Rory, I think the tag has broken." And I said, "What do you mean?" She said, "It's just really weird. The signals have gone really weird." And I said, "Let's have a look at it." And it did look really weird to begin with, because the magnetometer traces were going up and down like a wave the whole time. But instead of it being completely regular, it was a bit irregular. Anyway, we looked at this, and it transpired that what this meant was and this only happens on completely dark nights, when there's no full moon. The birds sit on the water and they go round and round in circles. And these circles can, you know, it takes them about, I'm trying to remember off the top of my head, maybe 8-10 seconds to do a circle. And they're paddling and they're kicking, and you can see the kick, and periodically they'll put their head down and eat something, and then carry on doing this circling behavior. And the circling behavior, the limits we've had, I think, are about 40 seconds and 6 hours, 40 minutes. One individual bird did, and sometimes they don't do it at all. And what we think is happening is, I don't know how many of you have been in waters where the sea has been phosphorescent. So you get marine life that when it gets agitated, it glows, it lights up. And in certain parts of the world, that effect is really substantial. So what we think the birds are doing is they're kicking up the phosphorescence in the water, and they feed on squid. And the squid say, "It is beautiful, the light, I must go to the light." And the squid swims towards this pelota, probably is in Portuguese, a ball of light, and as it gets there, the albatross then grabs them and says, "Thanks very much." And so they're fishing with natural light. And as luck would have it, we formulated this hypothesis, and then we had someone go out to the subantarctic islands and put a whole load of systems, again, which Mark made, for measuring light underneath the albatross, so we could detect this light. Wow. And sometimes they don't do it, and sometimes they do. And all of the birds we equipped with this technology didn't do any spinning. However, what I can say is that any time now, we're about to get a whole load of data from Learan's albatrosses, which seem to do the same thing. And they have been measuring light. So I can't tell you exactly what's going to happen, but I think that's the story. And that, you'd never expect that. I mean, who would think of such a crazy thing? So that's the sort of fun you come across when you read the data from these tags out.
Okay, and I mean, you touched a little bit on this, but how can this So you're using this, but you also make it available to other people. And so it's my kind of two-in-one question is, what are other people using it for? And also, are they using it for conservation? Is this something that...
Well, it's interesting because in Swansea, we have the Swansea Lab for Animal Movement itself. So that's composed of
that's your lab, right?
Yeah, a number of researchers who are working on right across the globe, from mountain goats in the Alps to sloths in Costa Rica, to sharks in Australia, or condors in Argentina. There's a lot of different things. So within Swansea, we're doing that. We also work in tandem with people like Mike Scantlebury from Queen's University Belfast, and he's been doing a lot of work on lions. We have PhD students that go and help them with Frank Rossell in Norway on beavers, and everyone's got their own question. It's interesting to see that and Mark's listening, so I better be good about this, but I think Mark's tag is, really is the best of these type of tags on the planet. And certainly there's no software like this that other people can use. But of course, people are endlessly resourceful. So there are tags that sort of do a similar sort of thing, but very, very few that have this, amplitude, or have this sort of Rolls-Royce approach. And yeah, these are all sorts of different projects, which some of them are conservation, some of them are being pests. There are things like, what's the effect of barriers? You put a barrier up in a national park, like in Kruger, or so what happens when a carnivore comes against it? Actually, we found out the answer to that is the females go through the fence and the males stay sort of stupidly male on the right side of the fence. The females go and hunt on the other side. So yeah, it's for lots and lots of different reasons.
Okay. And so what's the sort of the strangest request you've had for using this?
Strange, well, I suppose the thing to appreciate is that you can, people are animals too, so you can use them on people. And perhaps the zaniest is we worked with a professor from psychology from Swansea who wanted to study the behavior of people on ecstasy. Quite interesting because you can give rats ecstasy, and a lot of rats on ecstasy go around in circles. And so he was interested whether people on ecstasy on the dance floor did more circling, and whether that was, whether the rat model was a good model for humans, because he's actually studying humans, not rats. Anyway, legislation being what it was, we obviously couldn't go and give people ecstasy and say, now go on the dance floor. But we gave a whole lot of people who admitted to regularly using ecstasy tags, and they got kitted out, and then on Saturday night they were being recorded, everything they did. And then they said the next morning whether they'd been popping ecstasy or not, and then we could have a look at the so that's pretty zany.
That's kind of a far cry from when you were creating something to check out penguins, I guess. Right?
Yeah, well, penguins, people, like I said, it's a good luck job. This is not a lecture in somewhere in Portugal. You'd have to just check your pockets, because we maybe I don't know what you get up to.
So, I mean, you're getting all this information. That what happens is you put the tag on the animal, you go out, and then how do you make sure that you get the tag back? Well,
that problem is sometimes trivial and sometimes really, really awful. So the most trivial, there's no coincidence that I work so much on penguins, which are obviously the world's most fabulous animals. I'm sure everybody agrees with that. If you work on penguins, the work we're doing at the moment is in Argentina. Well, it's not at the moment because apparently there's a virus thing going around that's stopping stuff. But anyway, you go to the colony of penguins. You have maybe 100,000 penguins in this colony. They're sitting on their nests. You take the penguin off the nest. You put the tag on its back with a bit of tape, actually, just around a few feathers. Put the penguin back on its nest. The penguin goes to sleep, as you saw from the trace, and then at some point in the middle of the night, it'll get up and go to sea, and then it'll come back maybe 2 days later, and then you take it off the nest again, take the tag off, and you never ever lose a device. effectively.
Yeah.
So that's one side. The other side is where, Emily Shepherd working on condors. And there's a paper just been published in the Proceedings of National Academy of Sciences. And I think they've been working on them for, is it 9 years now? And they've got 9 full, beautiful data sets from condors. But, that you to catch a condor, you put a whole load of rotting meat down on the side of the mountain. And then you wait and wait and wait and wait. And eventually a couple of condors, or maybe more, or maybe less, will come and land and start feeding. And then they shoot a net over them, catch the condor, put the tag on them, and then they fly off. And they also put, at the same time, a sort of satellite link. And then they, it's a condor. It can be Argentina today and Ecuador tomorrow, And the tag is programmed, again, one of Mark's smart things, you can program it to pop off if you want. So they're programmed to pop off exactly 10 days later at midnight. And at midnight, they're not flying, they're on a cliff. So you get a position and you say they're in the middle of the Andes, some godforsaken place, and somebody has to go and find it. And you hope you can find it. But there are instances where one tag, for example, fell off a condor, which was on a cliff. It fell down 200 meters, smashed itself a bit on a rock that it hit on the bottom, and it made a small hole in the side of the tag, and out of that hole popped the memory card, and it went into a stream, and it was never recovered. So the tag was recovered, but the data were lost. So sometimes it's really difficult. It just depends on the animal.
Okay, so do you have any idea of how many condors they tagged to get those 9 data sets?
Yeah, it's probably 30. But the thing about it is you when you're weighing up, the pros and cons, there are some questions that are really, really, really important. Things like, is a bird like the Andean condor going to fly into a wind turbine if you build it here, right? Mm-hmm. And, the thing about being an Andean condor, one wind turbine can ruin your whole day, These are birds maybe live for 80 years. You take one out, that's it. That's 80, and all the breeding they should be doing is just gone. So, the fact that and what has come out of this study is that condors are utterly dependent. They're like gliders, utterly dependent on rising air from the mountains and columns of air going up, and lots of air in the same way wind turbines are. So there's a bit of a conflict here. So you have to say, well, where do they go? Where don't they go? And you could still put wind turbines, that sort of thing. So you might lose a few, and it's a lot of work, but the data you get are really worth their weight in gold.
So valuable, right? And you can always have a situation like the albatross where you might end up finding out something that wasn't even what you were looking for, but could be equally.
Well, that's one of the most incredible things about this this stuff. And I remember when I was first using this type of technology, actually on penguins, again in Argentina, and I got a tag back, and I was looking at the data, sort of like we were a bit earlier.
Yeah.
And I had an assistant with me, and she said, "What the hell are you doing?" And I said, "Oh," she said, "You just sat. You're like a zombie. You've been there for the last half an hour just looking at these lines." I said, "You don't understand. This is a book that has been written by a penguin. It's a diary. It's got everything it did today and yesterday in this diary. No one else has ever read this. I'm the first person to read it. It's an honor and a privilege, and it's really exciting. And you never know what's going to come out." And then I explained to her, and then she understood. So, the thrill of opening up a new book, particularly on a new species, once you've got lots of penguins, you know roughly what's going on, but a new species, I never thought they did that sort of thing. Yeah. So, yeah. Amazing.
Okay, I could carry on chatting to you forever, but I think there are other people in the room who might want to ask some questions too. So, Joanna, do you have some questions for us from?
Yes, we have some questions here. So I will start for the first one. Just let me. Okay. So we have Marta here. Can we see the device in Alice or other penguin, where and how it is placed? I don't know if you have an image, so maybe we explain.
The device in Alice on
a penguin. So is there a photo of a penguin with the device on it at all?
I should have prepared about this. Okay, look, here's the penguin. You see this? This is a penguin. And so this is, let's do it like this. So Oh, it's very difficult. But this is the penguin, and this is...
Hold it in front of you, maybe, Rory, because otherwise your background eats it up. That's it.
Okay.
Yeah.
Let me just move this down. How's that? Can you see?
Okay. Yeah.
So here's the penguin, and the device. I'll do it with the pen because it's easier to see. So the device, we put the bottom of the penguin down here, the lower back just by the tail, in the body center line. It's very small and very unobtrusive, but actually penguins, it's really important to get, different animals have different attachment systems. It's really important to get it right because you want to impede the animal as little as possible. Penguins are extremely streamlined, and if you start putting devices too far up the body, then you increase their drag. It makes it harder for them to swim. They use more energy. They can't dive as deep, swim as fast, catch as many fish. So we put them down here. Stupid of me not to have photos. I'm just wondering if I've got any on my computer down here.
And basically, you just sort of sellotape it on, I guess, is it? Is that?
Yeah, well, there's a whole technique, which is where you, if you imagine these are the feathers, you lift the feathers and then you stick some tape underneath, sticky side up, and you do this about a few times, and then you put the device on top of there and then wrap the tape around the device. That's really badly explained. But the point about it is this is a fairly standard technique now for birds, and what's important about it is when you take the device off, you can unwrap the penguins can't deal with tape, which is fortunate. So when you unwrap the tape off the bird, you take the device off, and then the feathers are pristine. There's no glue sticking on them. They're just the same way they were when they started. So.
Cool. I guess for different animals, as you said, you develop different ways of attaching these tags.
Yeah, sharks. In sharks, would you like to see? I wonder if I can find it. Just trying to think if I've got it. I must have it somewhere. Tagging a whale shark. I've got a film of tagging a whale shark. I'm just trying to think where I've got it.
Well, maybe we can sort of track down something later, but otherwise people will run out of time.
Yeah.
But so that gives people a basic idea of sort of, essentially you find a way to sort of stick this on.
Yeah.
So the next question is, how are the communication done with this kind of equipment?
Sorry, Rory already answered that. Because it's not online, you have to get the device to get the data. So
that's right.
That's right.
How do you communicate with the device?
Yeah. It's this one here, the one I was showing, has a micro card in it. But Alice, the new one, has a memory. So Alice will be connected, or is connected to an electric, to a little plug to get the data out of it.
Mm-hmm.
Okay, thank you.
So now we have another question from Carlos, where we can see this useful information.
So we'll be dropping a few links in the end, including a link to, in the chat at the end, including a link to Rory's lab. So I think that's possibly the best place to direct people, is it?
Yeah,
Rory?
yeah, it's a good idea, yeah.
Okay. Okay. We have people saying that they love your story.
Oh, well, that's nice. You mean that I sort of assumed every screen that had gone black meant they were just sleeping.
It's not that late here, Rory, and the Portuguese stay up late, so at least your Portuguese crowd is with you, don't worry.
Right.
We have another question from Carlos, and how can we know it, unfortunately, if the penguin was not eaten by a predator?
Well, that's an interesting question. If the penguin never comes back, if it's got a nest, well, there's a pretty good chance it's been eaten by a predator, but mainly they come back, and rather few penguins. I mean, I know you always see in television penguins being eaten by leopard seals and stuff like that, but actually very few of them in real terms do get eaten by predators. So yeah, it's possible though.
We have another question. What are again the recording parameters that you use? Temperature, speed?
Temperature, speed, we don't always record speed. Speed's a difficult one, but we certainly have had devices with speed on them. Temperature, pressure, and that can be pressure, underwater pressure, so in other words depth, or it can be air pressure, so altitude as well. Triaxial acceleration. Acceleration we measure in 3 axes. Triaxial magnetometry. Yeah, and those are the main parameters, and out of those parameters you can pull the animal's behavior out of them. You can reconstruct its movements. you can measure some environmental parameters, and you can look at energy expenditure or proxies for energy expenditure. So there's some really important animal parameters in there that come out.
I think that ties into the other question that came up, which is someone is asking, and Isabel Campos is asking, basically, how do you map this data? How do you know that in that graph those lines mean flipper beats or mean feet? Did you put this on an animal that you could see so that you could figure out what the tag was doing? How do you know that? I think is the essence of that question. That's
a really good question. And the simple answer, there's quite a few people now using accelerometry. If you saw the acceleration trace. And there's quite a lot of people that use accelerometry. And I think it's true to say that when people begin, they like to, if you put a tag like this, say on an elephant, you have the tag recording and you look at what the elephant does, and then you say between 3 and 4 or whatever, the elephant was just walking, and then you look at the tag data and you say, so that means walking. And that's where a lot of people work and what a lot of people do. However, these tags are recording something very specific. They're recording, in this case, acceleration, for example, and that acceleration, it's not witchcraft, it's a proper physical parameter. So even if you've never seen your animal do stuff, if you've worked with it for long enough, you could say, this is the body angle, this is the orientation of the animal, this is what it's doing. So you can look at, I can look at data from animals and say, my goodness, I didn't realize it, but it's a badger and it's doing somersaults, for example. It's learning and then appreciating that these sensors are proper physical sensors, and you just have to know how to interpret them.
So there's a follow-up question from that, which was whether you can tell from the data if the animal is injured.
I'll tell you something that's really interesting, something we're working on now, which is called animal state. Now, a lot of biologists don't like to talk about animal emotions. They say animals have no emotions. We're the only ones that have emotions. If anyone has got a dog, it's quite difficult to persuade them that their animal doesn't have emotions. Of course, animals have emotions. But what a lot of biologists therefore call it is affective state. And it's easier for them to understand conditions like stress or relaxation or so on. And we've been doing quite a lot of work in looking at the way animals move with respect to various conditions. One of them is, we've been looking at cattle lameness, and domestic animals that go lame. So they've got one leg not working, and then they produce a very particular signal in the acceleration. You can say, oh, it's lame.
So they're limping, effectively.
Limping, exactly. But also you can go much further than that. And this is a game I used to play in airports when we went to airports. As you could sit there and watch people walking past, and you can tell if they're stressed or happy or sad or whatever, just by looking at the way they walk, because they just walk in different ways. And we've been looking at the signals, the acceleration signals from animals with that in mind. And we've discovered, for example, that we can tell whether a penguin's eaten, just by the way it walks, whether it's eaten a lot or not eaten, or whether it's going over sand or gravel, or whether it's going up a slope or down a slope. So the basics of behavior, saying walking or not walking, is actually the tip of the iceberg. We can do much, much more. And we've got someone starting a PhD now who's looking at, or going to be looking at, she's trying to get the tags on at the moment, elephants that crop raid in Africa. So they go and steal people's crops, and apparently they get all hyped up before they crop raid. So she's going to be looking at the way they move according to stress and according to when they're going to crop raid. So there's all sorts of fun things you can do.
Okay.
So we don't have many more questions. I don't know. Do you have more questions?
Oh, I have an endless supply of questions, but I think we're also reaching the end of our time.
Yeah.
So I think that I don't think I can let this end without just asking Rory, does this hurt the animals?
I'd be stupid if I said this has no effect on the animal. Okay, that would just be a lie. And anyone who deals with wildlife and puts anything on them, it can just be a simple transmitter or a ring, is kidding themselves if they think they're not bothering the animal. That has two sides to it. One side is the simple capture of the animal is a really stressful thing. When you get caught as a wild animal, it normally means you're going to be eaten. Okay, so that's a really serious thing that's going to happen to you, and therefore physiologically you're perfectly right to panic, and that definitely happens. If you're very good with your animals, if you spend a lot of time with them, and you can, like with the penguins, you can pick them up and you treat, you know, and handle them carefully, then you can reduce that effect. But it's difficult. It's frankly difficult not to incur detriment as a result of the capture process. Whale sharks, we tag when they swim past us, so they just swim and you go click and you click it on, so they're not restrained. And then we are actually working on a new system for tagging animals automatically for things like hedgehogs that push their way through a hedge, and they go through, and then a little arm comes out and goes, puts a tag on it, and the hedgehog says, "What was that?" Well, never mind. The idea is to reduce the stress from that aspect. But the other aspect is then, how much does the tag itself affect the animal? It will always affect the animal, I think. There's the psychological effect, and often that's not too bad, but there's also the physical effect. I was talking about drag, you know, the resistance of a penguin when it swims through the water and it puts something on, then it has a higher resistance, needs more energy to swim. If anyone wants a good demonstration of drag, I discovered this when I was at school. Instead of swimming in a swimsuit, swim in your pajamas, and you will discover what drag is. And so whenever we work with an animal, we have to reduce the size, the footprint effectively, the drag, the mass, all these things to minimize it, so that whatever we're doing to the animals, it's minimum and acceptable. And then it's this balance between what's acceptable and not acceptable. And there are, I know we're going to stop, but I'll give you an example of something that happened to me years ago when I was working in Germany, and I'd had some titanium housings made by a local company, and it was for a temperature sensor, which was to be put inside it, and I was going to give this to albatrosses to swallow to find out when they were feeding, because when they feed on something, it's cold, and then the temperature in the stomach goes down. And I went to pick up the housings, and a woman came to me and she said, "Do you know what this is? This is animal torture that you're doing. It's animal torture, animal torture." And I said, "Have you got a moment so I can explain?" And she said, "Animal torture." Anyway, after 5 minutes, she stopped enough for me to be able to say to her, "The study is on wandering albatrosses. The population is crashing. We think it's something to do with feeding and getting caught on fishermen's hooks. The only way we are going to find out about this is to find out exactly when and where they're feeding, and this is how we're going to do it." And I said, "There is no question that when I walk up to a wandering albatross and I give it this tablet to swallow, it hates me. Okay, it is bothered, it is, phased, but it will not."
Fair enough.
It will not. Fair enough. It will not. They swallow 2 kilogram squid, so a small tablet's not going to bother it, but it is bothered by me catching it. And I said, it's not going to desert its nest, and it's not going to suffer more than temporary discomfort, and that's me holding it. But I said, to be perfectly honest, if to solve this problem, I had to kill a bird, I would do it, because if we don't find out, then by 2036, the population is predicted to be extinct. Now, I ask you, would you like your grandchildren to be around with no wandering albatrosses or not? Because if you say to me, I don't, it's animal torture, don't touch them, then they won't have any wandering albatrosses. And she said, "Oh, I'm really sorry. I didn't realize." So there's, it's a balance.
Okay. On that note, I think our time is well and truly up. So I'll pass over to Joanna for closing remarks, but I just want to say thank you again to Rory for an amazing talk. It's always really fun to learn about these things. And I'm going to drop a few links in the chat for Rory's lab, as I mentioned, but also a couple of other places where you can listen to and watch and read about Rory telling you more about this stuff. So there's a podcast, a video, both in English, and then there's an article in Portuguese and on SPEA's website that we publish on our magazine as well. So if any of you are members of SPEA, you will have read it already, but you can refresh your memory, or if you're not members, you can have a look. So I'll just drop that in now, and then I'll hand over to Joanna to finish. Thanks so much, guys.
Thank you very much to everyone for your time. Just to remember that this webinar will be online in Festival YouTube. Maybe tomorrow. I'm not sure if my colleagues will have time today. So if you want to see again, you can go there. And that's all. So I will thank you very much, Rory, for your time. I hope to see you again.
Pleasure. Well, thanks for listening if you have been, and if you've been sleeping, I hope it was a good sleep.
No, I think most people are smiling, and they're still here, so we already passed the time, but they're still here, so I think it was very interesting. So, okay, Sonia, you already shared the links, so...
Yeah, the links are in the chat. We can say goodbye. There's more webinars coming up for the next 3 days, so if anyone wants to join any others, you can also just go to the festival website and the links will be on there. Even if you haven't registered, you can still join. There's a couple in English as well still coming up, so if Rory and Mark want to join, you can also join us there. Have fun.
Cheers. Bye.
Thank you.
Bye.